Okay, rule number 2. Now suppose our function now is like 8x raised to 3. So there is now a number before the x cubed. If this is f of x equals x cubed, then we just use the first rule for integration. But with the presence of 8 in the x cubed, what should we do? Okay, so let me explain. If we wish to find the integral of 8x cubed dx, the rule is you can put the constant, the number 8, outside the integral, and we will have 8 times the integral of x cubed dx. So this is allowed in integration. And once you do that, you focus on the x cubed. So just copy 8 and then perform the integration on x cubed. And that is x to the 4 over 4 and then plus c. Now, you might say that this will result into a distribution of 8, which is correct. So that's 8 times x to the 4 over 4 is 2x to the 4 plus 8 times c. However, there is no need for you to write 8 times c, because since c is unknown and we don't know exactly the value, then we will not know what really is 8c. So in general, you can just simply say 2x to the 4 plus the c. So from the example, we can understand that the rule is, if you are given the integral of ax to the n, where a is like our 8 dx, then we can put the a outside of the integral, and then it becomes a times the integral of x to the n dx, and we simply perform the process on xn for the integration, and that is a x to the n plus 1 over the n plus 1 and then plus c. So the integral of ax to the n is ax to the n plus 1 over n plus 1. Now, if you take a look at the result, we can actually skip this step. We can just proceed by adding 1 on n, and that makes it n plus 1 divided by n plus 1. But why did I show this step to you? The reason behind is for you to know what you can do with the constant if you have an ax to the n. So it is another rule for integrals, that you can rewrite it as a times the integral of x to the n dx. This will be helpful later on in other examples. But for the basic of integration, if we have ax to the n, we simply add 1 to the exponent and then we divide by n plus 1. But do not forget that you still have that a on the function. And another thing is, always put the plus c, because there are also other functions in which the derivative will be ax to the n. So let us try the rule. Suppose we want to find the integral of 5x to the 4. Then this means 5 integral of x to the 4 dx, or 5x to the 5 over 5 plus the c, or x to the 5 plus the c. Okay, so that means the integral of 5x to the 4 is x to the 5 plus c. Now for the next example, let us now skip this step. Let's say you have 6x squared and then dx. So the integral is focus on the 2. So you have the 6 is there, x raised to 2 plus 1, which is 3, divided by that exponent 3, so you have over 3, and then the plus c. So this means 6 and 3 is 2, so you have 2x raised to 3 plus c. So this is the answer. So again, the rule that we have used, so this is our second rule, and that is if we have the integral of ax to the n dx, this is simply a x to the n plus 1 over n plus 1 plus the c. Once we know these two basic rules, we can now find the integration of any polynomial function. So let's say now that the f of x, the function is 10x to the 4 plus 8x cubed minus 6x squared plus 2x plus the 3. So the integral of f of x with respect to x is the integral of 10x to the 4 plus 8x cubed minus 6x squared plus 2x plus the 3 and then dx. Now to find the integral of this function, all we need to do is we split the polynomial function and get the the integral of each term. So this means that there is a rule that allows us to separate a polynomial function in the process of integration. So meaning to say, this can be written as 10x to the 4 dx, so it's being separated, plus integral of 8x cubed dx, so that's for the second term, and then continue, so you have minus 6x squared, so minus the integral of 6x squared, and then plus the integral of 2x, so we have dx, and then dx, and then plus the integral of 3 dx. So get the integral of each term, and you have 10x to the 5th over 5. No need to put the plus c yet, because even if you put the plus c in all the integrals, you will get a general plus c. So we proceed to 8x cubed, so 8x to the 4 over 4 plus c, so keeping that in mind, minus 6x cubed over 3 plus 2x squared over 2 plus the integral of 3 dx. Well, the integral of 3 dx is 3x. In general, for any constant, the integral is simply taken by attaching the x on the constant. So you have 3x. And then you have plus c, which can be taken as all the plus c's in every or of all the terms. That's why I said there's no need for you to put those plus c, because in general you will have a plus c for the polynomial function. The final step is to simplify the answer. 10 over 5 is 2, so 2x to the 5 plus 8 over 4 is 2, x to the 4, 6 over 3, so minus 2, x raised to 3, 2 over 2 is 1, so x squared, plus 3x, plus the c. So that's how you get the integral of a polynomial function. You need to split the polynomial into the integral of each term and then perform the basic rule of integration, And in the end, do not forget to put the plus c. Now, one observation that you should make is that once you get used to finding the integral of a polynomial function, you should be able to see that you can omit this step, because we can go straight to this step and use the basic rule. So why did I show you this step if we can skip that step in finding the integral? The reason behind is for you to know that we can split a given function into the integral of each term or the terms of the polynomial function, which could be useful in other problems later on. Okay, to sum it up, we were able to see the basic rules for integration, and let's name them. So number 1, so these are the rules. The integral of x to the n dx is x to the n plus 1 over n plus 1 plus c. Number 2, if there is a number attached to x to the n, we still use the rule, but don't forget the a, so n plus 1 over n plus 1 plus c. Actually, if you think about it, number 1 is just an example of number 2. But I showed it so that when you are given a simple x raised to a number, you can get the integral immediately. And finally, number 3 is the integral of a polynomial function. Now for a polynomial function, all you have to do is split the polynomial by the terms and get the integral by applying either the rule number 1 or rule number 2. Okay, so that's for the basic of integration. Integration is the reverse of differentiation, because integration is finding the antiderivative of a function. Okay, so that's all for this video. Thank you.